So yeah, this is my great pleasure to give a talk here today. I'm gonna talk about IGRINS-2 as one of a team member in the development team at Kashi. So here is some background of the development. So in 2018, the Kashi was joined to Gemini with a full partnership, and within the agreement, the Kashi we agreed to develop the facility instrument, which is very similar to IGRINS, and we are planning to go to Gemini-North. This is the key milestone. So we started from 2020, and we had a kickoff meeting, and then we had the CDR review for the upgrade in the same year. And this year, the sleep-ion camera test in the lab was one of the important tests. And our goal is to ship our instrument, and then we have the commissioning and then operation in the second half of next year. So here is the major science requirement. Maybe you have seen it before many times. So we cover from the 1.5 to 2.5 micron with the over 40,000 resolving power with high sensitivity. And at Gemini, we have like a 5 arc-second slit length. And this is optical design of IGRINS. So here we have the telescope beam coming in, and here is input optics, sleep view camera, there is slit. And this green thing is our main disperser, which is the immersion grating, one of the key elements in our instrument. And we have two channels, the H and K band camera, and each camera is equipped with H2RG detector. And on the right-hand side, we can actually see how the real optomechanical design looks like. This is the photo of original IGRINS. So one of the greatest thing of IGRINS is we have a very broad spectral grasp. With a single shot, we cover the whole H and K band in a single shot with two bands. So you can see this example, the pipeline output covering whole bands, and we cover about over 40 orders with a single shot with this two-channel camera. And I will just briefly go over the science case. IGRINS is near-infrared high-resolution spectrograph. So of course, the young cell object evolution and they're studying their disk is one of the important topic. And the stellar population and chemical evolution is also studied. And also RV studies toward binary brown dwarf, and also exoplanet is interesting topic, and we can also do interstellar medium stuff. So for the IGRINS science example, actually before my talk, Megan Tenok showed one of the great example toward the brown dwarf, which was really nice. And here's more example for young cell object. So Sokar et al. Showed the characterization of the T double hydride, showing including CO band head and titanium line, which is sensitive to the magnetic field. In the bottom, you can also see evidence of accretion burst with the long-term monitoring with the IGRINS. So actually, Song-Young is presenting this result tomorrow. And yeah, also exoplanet the study is going very actively, which is really interesting. So Line et al. Showed the detection of the hot Jupiter's atmosphere feature and the estimated the carbon and oxygen abundance. And actually, Dr. Megan Mansfield also will talk about her study about the atmosphere of the exoplanet today. Will be interesting. And also ISM study like such as planet nebula, detecting new species from the PN, and also the bottom one is the detection of unshocked material, the circumstellar material from the supernova remnant, which is Cassiopeia A. Yeah. And I want to switch to the development status of IGRINS-2. So I want to introduce our team. So Chan Park is our PI, and Youngsam Yu is the project manager, and Insu Yu is also supporting. So Yunjong is leading optical work, and Sang-hyuk is doing a lot of work with optomechanical development. And for electronics, Muyong is leading. I think he is in person today here for the conference. And Hein is doing software. Maybe she is here also too. And I am doing the systems engineering work. And I want to also introduce Gemini team. So Hee-hyung Kim is the project manager, and Brian Chen is doing systems engineering. And also John White and Eduardo Tapia is helping engineering support. And Francisco and Ignacio is helping developing software. And also Agile science operation support, Pablo Prado, Hwan Seo, and Jennifer Miller is also helping us. For advisory members, the Ruben Diaz is the project sponsor, and Tom Hayward is also advisory member. So maybe you want to know what IGRINS-2 is from IGRINS, the original IGRINS. Actually, by requirement, the specification remains the same, but there is some change because it has been 10 years since we developed IGRINS. Some part is not available anymore, and we wanted to make some upgrade within the given time schedule. So here is 3 major changes and upgrade in IGRINS-2. For optics, we upgraded the slip view, field of view, and for mechanics, we improved the light tightening, including use of one body radiation shield. And for the electronics, use of MACI, the board for the detector controller was one of the major change because the JADE2 was originally used, but it is discontinued now. So among these 3, I will just highlight the optical design change. So on the left-hand side, there is the original slip view, field of view of the IGRINS. This is actually why we had to cut some part of the slip mirror surface due to secure our science beam at the time. But after we did some design study for IGRINS-2, we found that we can kind of simply upgrade the field of view, and with that we can get better target acquisition and to better utilize detector area. So in the actual optical design, there's part for the input word mirror. We could just shift this part with few millimeter and then move other following optical element a little bit, and then we could be able to get the full field of view in the optical design. Also, the mechanical design was changed accordingly. And I want to switch to show photos to show what we are actually doing in Kashi lab these days. So this is photo of slip view camera detector. You can actually see the surface of H2RG detector here. This is the assembly of the slip view camera. And here is the full bench of assembly showing input optics, slip view camera, and slip view camera, the optics of slip view camera, and the slip view camera detector. So here is the scene that we are moving in and out from the clean room to do the detector work. And in the bottom here, you can see how the MACI board looks like. And here is the photo of radiation shield. And here you can see we are closing the chamber cover in the lab. And here's also the web monitoring tool to monitor all the temperature and the pressure status, which is available online. Here is the stack of temperature controller here. And here's more for the showing our people. So Haini is working on software work, and Sang-hyuk is doing the assembly. Here is one of our group photo during the detector mount assembly. And Ujong is taking the test image here. And actually we have a group chat because for more effective communication, we made this group chat, and at this time we are very happy with our first the slip view image here. Yeah. So I'm switching to the alignment of the slip view camera detector, which I mentioned that we did earlier this year. And the method is that the alignment of sleep view camera means we are testing the part highlighted here with a red box. And we use the part called the sleep test mirror, which has a very narrow pattern on the surface. So we installed this sleep test mirror instead of a slit for the test. And actually the slit surface is kind of tilted. So we can use the in and out focus phenomena to find the best focus of sleep view camera. So here is Gmax simulation for the test. So here, this is real setup for the test. So the sleep test mirror is look like this, and then it is installed at the position of the slit. So here is slit, and here is detector. So after that, we were able to get our first image in May. So we are very happy to see this image, although the focus was not perfect yet. And at the same time, we were able to confirm that we successfully got the circular shape of field of view of sleep view camera after our optical design and optomechanical design change. And we were happy to see it. And after that, we had to optimize the focus of the sleep view detector. So by our design, the sleep view detector, the position of the sleep view detector itself is a compensator. So the changing the position is available by changing the part called bumpers here. So we can replace the size of the bumpers with a different size, and then we can move the focus of the sleep view camera. So we did some iteration to find the best value through the many cooling cycle, and finally we find that 1.8 millimeter movement made the focus perfect. So here you can see how we are getting close to the best focus by moving the physical position of the sleep view camera. So in the back there is first image, which was not kind of out of focus, and after that we moved it 1 millimeter, and then finally we got 1.8 millimeter adjustment. Then we have clear image. So if we draw the vertical line like this, here is where the slit will be located when we install the slit. So we see the focus is good here, and then if we draw a flat crossover this horizontal line, you can see the focus is a Fourier transform is good at the center. This is an example of the cooling test during the alignment. So we are having about 2 days of cooling time now, and then we are trying to reduce the time, and by adding each component, we are keeping the cooling test in the lab. And for the software, Kashi team and Gemini team is communicating closely to make the IGRINS software to be the facility instrument. So for the observation software, which is called the OBS app, we are developing now, and also the engineering tool is under development. So I want to mention that in this long COVID situation, we had to work remotely together. So there was kickoff meeting and CDR in remotely, and Kashi team was providing kind of a virtual tour for Gemini team to show our photos and videos in the Kashi lab. And finally, actually last week, the team was able to meet in person in SPI meeting in Montreal. Actually, myself was not there, but we were really happy to see each other, and hopefully we see more in person. And this is my last slide. So we have about a year before shipping. So according to the schedule, we are now on schedule. And in the second half of the year, we are proceeding to the spectral camera alignment. And also the documentations and test report will be important. And the detector about the detector procurement, we need 3 detector, which is a sleep view camera and a chain K band. So we have 2 detector in the lab, and we have installed in IGRINS-2 already. And another science grade will be delivered early next year. And we have confirmed it with the Teledyne. And we expect more face-to-face interaction. Actually, some Gemini members will visit Kashi after this GSM. And then, yeah, we are expecting another visit in October. Okay. Thank you. Sure.
Thank you. Questions? Anyone online? Nope. Yes.
Hello.
Yes.
This is amazing.
Thank you.
Thank you for your talk. And this instrument is kind of upgrade of IGRINS.
Yes.
So, but when this instrument is already, you are planning to use both IGRINS instrument, one in the Gemini-North and one of the Gemini-South simultaneously. I think so.
Oh, yeah, I think it's actually depending on what Gemini planning to. Yeah, actually, yeah, maybe he wanna answer.
The Gemini, the IGRINS-1 will stay with us till 2024 A semester. That's the current plan. Of course, we can, yeah, there will be change, but so far, yeah, it's gonna stay in the Gemini South for 2 more years. Can you hear me? What? Oh.
Yeah, I think we're aiming to be having sort of a very minimal time between the 2 instruments. So when we know much better when IGRINS-2 comes to Gemini-North, then we will likely then stop IGRINS, because we're also getting new instruments at Gemini-South with Scorpion. So it's likely no overlap of the 2 of them at the same time. But we aim to have that programs could continue in theory, large and long programs between the 2 sites.
Okay, thank you.
So no. Okay. Well, thank you very much.
Thank you.
Young again.